So our first activity here was checking out this fusion game, right? Trying to get to this iron element. And what we were looking at here was essentially the core of a star. And within the core of the star, there are some hydrogen atoms. And as you start to play the game and swipe, a couple things are happening, right? More hydrogen atoms are appearing, and some of them are combining to create other elements. So what we're essentially doing here is creating fusion within the core of this star, and by doing so, moving our finger, we are representing gravity. So in your assignment, you were asked to come up with two ways that you can show, or one way, I guess, to show gravity for a low mass star and a high mass star. And in the background of our assignment, the directions, we found out when stars are more massive, they have more of a gravitational pull. So we're essentially trying to figure out how we can represent more gravity or less gravity by moving our finger. So, lots of different ways people came up with ideas, but those ideas were shared in your assignment by doing two simulations. One for a low mass star and one for a high mass star. And so what we did in class today was we made a T-chart here, kind of doing a little compare between those two. Both low mass and high mass star. And we started out with what we knew from the background of the assignment. We know mass means stuff, how much material something is made up of. So we started with size. We know low mass is looking at typically smaller stars, while high mass is looking at larger stars. And in terms of gravity, again, in the background, we underlined or highlighted the idea that larger stars, more mass, have higher gravitational pull or stronger force of gravity. Therefore, a lower mass would have a weaker gravity. And so here's what we did upon comparing our two attempts, low mass and high mass, is first we looked at these energy points. And we have to remember what those energy points are representing. Those energy points are essentially thinking about how much energy the star is making. And the reason the star is making this energy is because of fusion. So if there's more fusion happening, we should see more energy points. So when we think about our two stars and look at our energy points, and this is what I got, and when we talked in class, there were people that didn't have low as low points and high as high points. But when we looked at a consensus, a majority of our students, we did typically see that energy levels were higher in a high mass star and lower energy in a low mass star. And again, that is because the amount of fusion that's happening to create those higher levels of energy. For example, this high mass star having more fusion is moving the elements together more and more, creating more fusion and therefore a high energy environment. Low mass stars are, of course, less fusion. Our final thought that we considered today was lifespan. How long the star will last. And typically we think, oh, well, there's more energy here in a high mass star, so it should have more energy to last longer. But what we have to consider is what the energy is doing or where it's coming from. It's coming from fusion. So here in the high mass star, the more I fuse elements together, the more energy we get. And I'm using up all my small elements pretty quickly. And I'm starting to see these bigger elements form. And some of the bigger elements are fusing together while others are not. And hopefully what you noticed is the longer or the more that you swiped wasn't necessarily the longer that you were playing, because you were still doing this in your 90-second trial. But maybe you noticed that your star died out. I thought maybe I could get it here, but I'm not. So again, in class, we talked to students and we compared. Some people had stars die out because they lost energy and some didn't. But moreover, the students noticed that the high mass stars were the ones that died out. And that was because they have a shorter lifespan. They are trying to keep their star at that same level of energy by doing that much fusion nonstop. So they're burning through their fuel much faster than a low mass star that's going to have a longer lifespan. So I like to use the analogy of a semi miles per gallon versus a Mini Cooper or a small car miles per gallon, right? The big semi, even though it has a big fuel tank, it has a miles per gallon of about 3.5 to 5 miles. It only can go that distance per gallon of gas. A small little car like a Bug or a Mini Cooper, they can get anywhere from 30 to 40 miles per gallon, maybe even more. And I drew these backwards. That's because it's only needing to energize this small vehicle down the road, where here, this large semi needs to be energized and continue at that same level of motion. So I need to continue giving it high levels of energy, which means I'm going to run through it much faster. So as you record your T-chart and kind of think through those ideas, you're compiling that information here in Learning Target 1. High mass star, including all the keywords, and low mass star, including the keywords. Making sure you're hitting all points of the question: mass, gravity, fusion, and lifespan.